When you say Darjeeling, two things come to mind: the tea gardens and the toy train. This toy train has been accorded the UNESCO World Heritage status. While running on the track, it offers breathtaking views of the mountains and valleys. But have you ever observed the track on which the train runs? Notice that it is not continuous. The railway tracks are made by joining small units by thermite reaction. In thermite reaction, aluminium is made to react with processed iron oxide, forming aluminium oxide and molten iron, which joins the two units of railway track permanently. Aluminium displaces iron from ferric oxide to form aluminium oxide and iron metal. Therefore, it is a displacement reaction. Let's go to the laboratory and perform a simple experiment to get a better understanding of displacement reactions. Take an iron nail in a test tube. Add a small quantity of copper sulfate solution to it and leave it for a day. Observe it the next day. Did you notice any change? The blue-colored solution of copper sulfate changes to light green and a reddish-brown layer of copper is deposited on the iron nail. It happens because iron is placed above copper in the metal activity series and is more reactive than copper. Iron displaces copper from copper sulfate solution. Here, we have observed that the product of the reaction between copper sulfate and iron are iron sulfate and copper. So, what information can you gather from this activity? A displacement reaction is a reaction in which an element displaces another element from its compound. So, now you have understood what displacement reactions are. Can you predict which of the two reactions would occur? The first one, where lead reacts with a copper chloride solution, or the second one, where copper reacts with lead chloride solution? Out of the two reactions, the first reaction would take place. But on what basis can we decide which metal would displace another metal from its oxide? The answer is reactivity series. Reactivity series of the metals is the arrangement of the metals in a vertical column in the order of decreasing reactivity. So, metals that are placed above in the reactivity series displace another metal from its compound, which is placed below it in the reactivity series. Now, you know about the reactivity series. So, can you predict the products formed in the first reaction? When lead is made to react with copper chloride solution, lead-2 chloride and copper are formed. It means lead has displaced copper from its salt. Whereas in the second reaction, copper cannot displace lead from lead chloride solution as copper is less reactive than lead. Let's understand in depth the displacement reaction by performing an activity. For this activity, we need test tubes, zinc granules and dilute hydrochloric acid. Take a few zinc granules in a test tube. Add a small quantity of dilute hydrochloric acid to it. What did you observe? The bubbles of gas start coming out. Let us identify this gas. Take a lighted candle near the mouth of the test tube. You will hear a pop sound indicating the presence of hydrogen gas. Zinc is more reactive than hydrogen and it displaces hydrogen from dilute acids. This is a single displacement reaction. Some other examples of displacement reactions are the reaction of zinc metal with copper sulfate solution, the reaction of zinc metal with dilute sulfuric acid, the reaction of iron metal with dilute sulfuric acid. Do you know that displacement reactions have various applications, one of which is in the steel making process? In this process, iron is extracted from its ore by heating the iron ore with carbon. Now, let's recapitulate what we have learned.